This is section 8.4, special right triangles. There are two special right triangles. There is the 45-45-90 triangle. There's the 30-60-90 triangle. The relationships of the sides of these triangles needs to be memorized. It's that simple. Let's take a closer look. In a 45-45-90, since these are both 45, they're congruent. According to the converse to the isosceles triangle theorem, then these two legs have to be the same length. We're going to be referring to those as SL for short leg. They're both the same size, so why am I calling them both short? Don't worry about it. Let's just call them short legs. If you want to just call them legs, that's fine too. Whatever the length of the short leg is, the hypotenuse is always the length of that short leg times the square root of 2. Always. So let's see how this works. So what needs memorized? This is what needs memorized. Opposite the 45s are the short legs, opposite the 90, the hypotenuse, that's short leg times the square root of 2. So I'm just going to bring this down. This picture, as I'm working through this, you don't need to draw this picture each time. Just want us to be able to see it. So here's how I'd like you to do this. Take the length of whatever side that you're given. Like in this case, we are given this here. Label what that's equal to. That's equal to the short leg. How do I know that? It's opposite of 45. In this picture that I want you to memorize, it's opposite of 45. Well, once you know what the short leg is, you know what everything is. The other short leg is 6, which the picture already shows. The hypotenuse is the short leg times the square root of 2. So that's 6 square roots of 2. Problem's over. Once again, this triangle that I drew here, you don't need to draw every time. Just using it for reference. Take a look at this one. If I put this in the same orientation, opposite the 45s, those are called the short legs. So whatever side you know the length of, when you're given one of these triangles, you will always know the length of one side. Could be more, but you would know at least the length of one side. Label what that's equal to. It's opposite 45, it's the short leg, so 2 is equal to the short leg. The hypotenuse is the short leg, 2, times the square root of 2. That's true in every 45-45-90. Done. Please note, this is also a short leg. It doesn't need to be labeled. We're just supposed to figure out what R is. Number 13 is a little different. Put this in the same orientation. You don't have to draw this triangle each time. You can if you want. It's just for reference. What side do we know? We know what's opposite 90. What's opposite 90 supposed to be? It's supposed to be the short leg times the square root of 2. Now our goal is to figure out what the short leg is. Short leg, if I solve this equation, I'm going to divide both sides by the square root of 2. If I divide 8 square roots of 2 by the square root of 2, I'm going to get 8. That's all the work you have to show for that part. Let me just show you a little bit of optional work if that doesn't make sense. We got short leg times the square root of 2 equals 8 square roots of 2. If we divide both sides by the square root of 2, the square root of 2's cancel. If you divide something by itself, you get 1. Therefore, the short leg is 8. Once you know what the short leg is, the rest of this should be easy. These are both short legs. In fact, once again, in a 45-45-90, the two legs are always the same length. So there's 3 examples of 45-45-90s. Let's now look at the 30-60-90 special right triangle. In a 30-60-90, since the angles are different, the lengths of the sides have to be different. Opposite of 30 is going to be the smallest side. That's going to be the short leg. Opposite of 60, that's going to be the long leg. That's whatever the short leg is, times the square root of 3. The hypotenuse, which is opposite 90, will always be the short leg times 2. So what I would ask that you memorize is this right here. Opposite 30 is the short leg, the SL. Opposite 60 is the short leg times the square root of 3. Opposite 90 is 2 times the short leg. Compare and contrast this with the 45, 45, 90. All right, so let's do this next problem. I'm just going to redraw this for reference. Our goal was to figure out what the short leg is, because once we know what it is, we can plug it in here, we can plug it in here, and we can plug it in here. Opposite of 30 is the short leg, so we know right away that's 4. Opposite of 60 is the short leg times the square root of 3, so that's 4 square roots of 3. Opposite 90 is the short leg times 2. 2 times 4 is 8. Problem's finished. Let's do another, shall we? Once again, this triangle I keep redrawing, that needs to be in your brain, needs to be memorized. Identify what side you're given. We're given the side opposite of 60. That's known as the short leg times the square root of 3. Well, what does that make a short leg? Well, if we divide both sides by the square root of 3, we're going to get the short leg as 5. Once you know what the short leg is, finishing the problem is typically relatively easy. Opposite of 30 is the short leg, that's 5. Opposite 90 is the short leg doubled, 2 times 5 is 10. Problem's finished. Number 6, you can redraw this triangle like I just did, or you can just have it in your brain. Opposite of 90 is 2 times the short leg. If you divide both sides by 2, you get the short leg as 1. Opposite of 30 is always the short leg. Opposite 60 is the short leg times the square root of 3. 1 times the square root of 3 is square root of 3. We've just seen 6 examples. If that's enough, stop this right now and go do the homework. In fact, I'm going to stop this video right now. I'm going to make a second video doing the next few examples. If you need to watch it, go ahead, and if you don't, then don't. You know what, on second thought, let me do problems 11 and 16. Then I'll make a second video to finish the other problems. Because 11 and 16 are a little different. Find the length of the diagonal of a square with sides 12 inches long. What in the world does this have to do with special right triangles, you may be asking yourself. A square has 4 right angles. All the sides are the same length. Find the length of a diagonal. Once again, each of these sides are 12. A square is a rhombus and a rectangle. The diagonal in a rhombus bisects the opposite angles, so that makes these 45s. So this has everything to do with the 45, 45, 90, because look what we have. We have a 45, 45, 90. Take the side you know the length of, and this side 12, opposite 45, that's the short leg. Set it equal to the triangle's symbol that you have memorized. Opposite of 90 is supposed to be the short leg times the square root of 2. The diagonal is 12 square roots of 2 inches long. Done. Number 16. One side of an equilateral triangle measures 20 centimeters. What does an equilateral triangle have to do with 30, 60, 90s, or 45, 45, 90s? Everything. An equilateral triangle, all sides are the same length. I'm just going to draw 2 of these for now. It says to find the measure of an altitude. An altitude, you'll recall, is a segment that goes from a vertex to the opposite side, forming a 90-degree angle. In an equilateral triangle, it's also a median, so each of these are 10. It's also an angle bisector. An equilateral triangle, we have 60-degree angles. If you cut it in half, you get 30 and 30. So what do we have here, boys and girls? We have a 30, 60, 90. We know what the short leg is right now. Opposite 30 is 10. Opposite 60, which is the altitude of this problem, is 10 square roots of 3, the short leg times the square root of 3. The altitude is 10 square roots of 3 centimeters. Done. Once again, if you don't need to see any more examples, go do the homework. If you do, I'll make a second video to show you examples 7 through 14.